Okay, so our new unit is going to be on rational expressions, and rational expressions are fractions. If you think of a rational number, that was the symbol Q for quotient. So to simplify a rational expression, I can only cancel factors. I may not cancel these y's. So I'm going to factor in my numerator, and it's a difference of two squares, so I can do y plus 9 and y minus 9. And on the bottom, I can factor out a 2. So now that I have all multiplication, I can cancel this whole factor with this whole factor, and I'm left with y plus 9 over 2. Same thing for number 2. I'm going to factor out a y on the top. And on the bottom, what multiplies to 7 that adds to negative 8 would be negative 7 and negative 1. I can cancel this factor with this whole factor, and I'm left with y over y minus 1. If you are tempted to cancel like this, I want you to think about this situation. If I have 2 plus 3 divided by 2, what does that equal? Well, that's 5 halves. If you were going to cancel, if you said these cancel, well, that's 3. That's the math jail way. You may not cancel those factors, these individual numbers, because of the addition. You can only cancel when it's a factor like this. So we're going to use this simplifying concept for when we multiply our fractions. To multiply, I'm first going to simplify individually each piece of each fraction. So the numerator on this first one can factor to x plus 3 and x minus 1. The denominator stays the same. On the top here, I can factor out an x, and on the bottom, it's the difference of two squares. So now, when you multiply fractions, that's across. You go across the top and across the bottom. So I'm going to make this one big fraction, x plus 3 times x minus 1 times x plus 2, all over x plus 2, x minus 1, and x plus 1. So I'm going to look and see, are there any common factors in the numerator and denominator that I can cancel? Well, this x minus 1 can go with this x minus 1. The x plus 2 cancels with x plus 2. So my answer remaining is x times x plus 3 all over x plus 1. Okay, so we're going to do the same thing here. Now, before I even start, I can cancel these 3's. So I'm left with negative x plus 12 all over x minus 12. Now, looking at this, I notice they're really similar. So if I factor out a negative 1 from the numerator, I can cancel my x minus 12's. And my final answer is negative 1. Now, dividing is multiplication in disguise. When you divide fractions, that's really multiplying by the reciprocal of the second fraction. So if I'm going to rewrite number 5 as a multiplication problem, I'm going to rewrite my first fraction. Now I'm going to multiply by the reciprocal, which means flip this fraction. So I'm going to combine this now to one fraction so I can simplify. And let's see what I can reduce here. The 1x squared can cancel with that x. 48 and 36, what do those both divide by? They can both, so 48 and 36, they can both divide by 12. So if I divide a 12 out of each of these, I'm left with 3 and 4. So now my final answer is 5 times 4x all over 3y to the third. Okay, we're going to use the same process for 6. I'm going to rewrite that as a multiplication problem. We have x squared over, but I'm going to factor this while I rewrite it. That's x minus 1, x plus 1. And then I'm going to take the reciprocal of this piece. Let's see what cancels. This x plus 1 and this x plus 1. This x and one of these x's. So on the top I'm left with x, and on the bottom 3 times x minus 1. Okay, so now we're going to do a combination of multiplying and dividing, which really, the easiest way to do these is change it all to multiplying. So for number 1, I'm going to get 6x over 3x minus 7 times, and while we're changing it to multiplying, let's factor out anything we can. I notice here these have a common factor of 3. And then I'm going to make this 35 over x squared. Okay, what can I reduce before I combine things together? This 3 and 21 can reduce to 1/7. This x can cancel with one of these x's. Oh, this 7 can cancel with 35. And I think that's it. So now 6 times 5 is 30. X minus 7. And on the denominator here, we're left with x times 3x minus 7. Do not be tempted to cancel anything with these minus 7s, because you cannot cancel just that negative. You have to cancel a whole factor. Okay, so for number 2, I'm going to factor each piece. So what multiplies to negative 6, that adds to negative 1. We're going to do negative 3 and positive 2. On the bottom, what multiplies to negative 15, that adds to 2. We can do positive 5 and negative 3. Okay, now we're going to factor the next. The difference of 2 squares. And on the bottom, x minus 5 and x plus 1. And then because it's division, I'm going to take the reciprocal. So x squared minus 1 factored is now my numerator. And on the denominator, multiplies to 6, that adds to 5. Let's do positive 3 and positive 2. Okay, let's look for factors that can cancel. X minus 5 and x minus 5. X plus 1 and x plus 1. X plus 2 and x plus 2. X minus 3s. Oh, x plus 5s. So my final answer after all that is x minus 1 over x plus 3. Okay, so here's 4 more problems. We're going to pause the video here, and I would like you to try these 4. And when we come back, I will have my answers worked out so that you can see them. Okay. This first piece is can't factor that. Now I'm multiplying by the reciprocal here and factor out the 3. And on the bottom, I'm going to factor out the 5. Now here I'm going to rewrite x plus y squared as x plus y times x plus y, and factor the bottom, the difference of 2 squares. Actually, this is the difference of 2 squares as well, so I'm going to rewrite that. Okay, let's see what can cancel. X minus y, x minus y, x plus y, x plus y. So our final answer should be 3 over x plus y. Okay, so when we don't have a fraction, you can pretend that everything's written over 1. So this first piece will factor to b minus 3 and b plus 3. The second piece, because it's dividing, I'm going to take the reciprocal and factor what multiplies to 15 that adds to 8. It's going to be plus 5 and plus 3. And then I need the reciprocal of this last piece because of the division. B plus 5s can cancel, b plus 3s cancel, b minus 3s cancel. I'm left with 2 as an answer. Okay, so for 5, I'm going to rewrite this one. But my denominator, I can factor out an a. Oh, and now I have a difference of 2 squares, so I'll factor that next. I need the reciprocal of this fraction, because it's division. And now from here, I can factor out a b. Oops, I shouldn't be taking the reciprocal of that one. This fraction is multiplying, so it stays, the numerator and denominator stay where they should. Okay. Well, what I'm going to do is rewrite this as a minus b and a plus b. Now to cancel a minus b, this ab, well, trying to think of what I should cancel. Well, let's do this b with this b, and I'll do one of these a's with this a. Alright, let's see what I can do this b with one of these b's. Let's see what's left. A squared, b squared, a plus c. And then down here, a times a is a squared, and a plus b. So I can do a little bit of more canceling. A squared and a squared go. So my final answer is b squared, a plus c, all over a plus b. Okay, and for the last problem, what multiplies to 64 that adds to 16 is positive 8. And I have the difference of 2 squares on the denominator. I need to take the reciprocal of this one. And I'm going to factor my difference of 2 squares. And then this is over 1. So what multiplies to 24 that adds to negative 11? We're going to do negative 8 and negative 3. Those cancel. Those cancel. Those cancel. Those cancel. So our final answer is x plus 8.